Welcome back to Discovering Geometry with Mrs. Berry. This is Lesson 49. Chapter 8 begins talking about area. Today we will talk about the area of rectangles and parallelograms. Area, in the geometric sense, is the 2D space that a shape occupies, or we could talk about it being the measure of the region enclosed by a figure. It is measured in units squared. We could say U squared. What occupations can you think of that would take measurements for areas? This chapter is about finding the area of different geometric shapes. Many formulas you have probably used before, but we will have physical demonstrations in the investigations to help us remember the ways to find area for different shapes. How would you find the area of this rectangle? You could count the squares, 1, 2, 3, 4, 5, 6, 7, 8, etc. Or you could look for an array. When we learned multiplication, we learned that it might be that we have 5 rows of 4 in each row. So we have 5 times 4. So we see that there are 4 squares across the bottom. So across the bottom, we have 4 squares. And we have 5 squares down the side. We know that 4 times 5 is 20. That makes 20 squares altogether. If we call the bottom the base and the side the height, it would come to be the base times the height for the area of the rectangle. So our rectangle area conjecture. The area of a rectangle is given by the formula A equals BH. A is the area, B is the base, the length of the base, and H is the height of the rectangle. Let's look at an example. How could we find the area of this shape? We could first look at the inner rectangle. So how big is that? It is 4 by 6, or 24 squares. How do we find the sides? If we look at this, it looks to be half of this bigger rectangle. And this side down here looks to be the other half. So if we just combine this one and this one, we would get an entire rectangle piece over here. That is 3 times 1, or 3. If we look over here, it's the same. We have 2 halves of this bigger rectangle, so we could say this bigger rectangle is 3. So we now have 24 plus 3 on one side and 3 on the other, for a total of 30 units squared. Since I don't know whether this length of the grids are an inch or a centimeter, I just call it a unit, and it's unit squared because this is 1 square unit. So let's use the area of a rectangle to find the area of a parallelogram. Any side of the parallelogram could be called the base, just like any side of a rectangle can. An altitude of a parallelogram is any height from one side of the parallelogram perpendicular to a line through the opposite side. So we could think of that as being the height of the rectangle. So the altitude is the same thing as the height. The altitude can be inside or outside the parallelogram because no matter where you draw the altitude, it will be the same height. So look at this. This height is inside where we would think of it being, but we could even scoot it over and we could measure it right here. We could even scoot it over a little bit more and measure it from out here. Any way that you look at it, the height is still the same. We're going to construct a parallelogram on a piece of heavy paper or cardboard. From the vertex of the obtuse angle adjacent to the base, draw an altitude to the side opposite the base. Label it like it's shown. So we have a base, and then we'll have the other side, and then we'll have the altitude or the height that's going to be perpendicular to that base. Cut out your parallelogram and then cut along the altitudes. So go ahead and draw another altitude here if you want, and cut along this altitude as well. You'll have 2 or 3 pieces depending on if you cut 1 or 2 altitudes. And what will be left? Either a rectangle, a square, or maybe a trapezoid if you only cut off one of the altitudes. Try arranging your pieces into other shapes without overlapping them. Is the area of each of these new shapes the same as the area of the original parallelogram? Well, it should be. The piece that you cut out is the area. As long as you don't overlap, you're going to have the same area no matter how you rearrange those shapes. Can you make a new shape a rectangle? So can you put those pieces together to make a rectangle with 90-degree corners? If so, calculate the area of this rectangle and then compare that. What's the area of the original parallelogram? So as you do this, you should be cutting off one side. And I think that you'll find that if you take that triangle and move it over here, so we have the new triangle over here, and we have the original. This was 90 degrees. You'll find that you have a rectangle right here. And it's the same area as the original parallelogram. So the area of a parallelogram is given by the formula A equals base times height. It's the same as a rectangle. A is the area, B is the length of the base, and H is the height of the parallelogram. As long as you remember that the H is the height of the parallelogram and not the length of that outside side. You want the height to be perpendicular to the base. Now we have a few more examples. Find the height of this parallelogram that has an area of 4.5 meters squared and a base of 2.5 meters. So if we think about our formula, area equals base times height. We're going to put in what we know. 4.5 for our area, and our base is 2.5. But we don't know what the height is. If we plug it in like this, then we can use our algebra to solve for the height. 2.5 is multiplied by the height, so we can divide by 2.5 to get the height by itself. So 4.5 divided by 2.5 gives us 1.8 for our height. So our height right here is 1.8, and then we need to list units. It's in meters. So our height is 1.8 meters. Last example. If the perimeter of a rectangle is 32 feet and the base is 6 feet, what is the height? So this wasn't from our lesson today, but we've done perimeter before. The perimeter is the distance around all of the sides. If we know that the rectangle is a 6-foot base down here, then we also know that it's 6 feet up here. We do not know the height, and the height is the same on both sides. So our perimeter is 32 feet. It is equal to the 6 feet on the top and the bottom that we already know, plus the height on both sides. I'm going to start leaving off my units for just a minute while I calculate. So 6 plus 6 is 12, and h plus h is 2h. I'm going to subtract the 12 on both sides. That leaves me with 0 plus 2h. And 32 minus 12 is 20. I'm going to now divide by 2 to get 1h by itself. And we will find that h is 10 feet. So the height is 10 feet.